Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC P050A, indicating a cold start idle air control system performance problem for the Honda Accord models from 2012 to 2017. This issue is significant as it involves the functioning of various components that are essential for the proper performance of the vehicle during cold start conditions. The primary components affected include the powertrain control module, PCM, the intake air control system, and the ignition timing mechanism. Understanding how these components interact is crucial for diagnosing and rectifying the problem. The DTC triggers a warning under specific conditions, notably when the actual intake air volume falls below the target volume, signaling a malfunction. Effective diagnostics can help in rectifying the issue and ensuring optimal engine performance. The DTC P050A signifies a cold start idle air control system performance problem. This code indicates that the powertrain control module, PCM, has detected a discrepancy between the actual intake air amount and the specified or target intake air amount. The PCM is integral as it analyzes various sensor data and controls engine functions, particularly the idle air control valve, IAC. The IAC is responsible for regulating the amount of air entering the engine during idle conditions, especially when the engine is cold. The malfunction occurs within the engine compartment, where these components operate closely together to ensure that the engine warms up efficiently. The quick warm-up system is crucial in reducing emissions by activating the catalytic converter as quickly as possible. Thus, accurate functioning of these components is vital for compliance with emission standards and ensuring smooth engine performance. Several factors can lead to the DTC P050 being triggered. First, the intake air duct may be broken or misinstalled, which can cause significant air leaks and impact the system's ability to function correctly. If the air cleaner is clogged, broken, or severely damaged, it can restrict airflow, leading to a failure in the idle air control system. A malfunctioning mass airflow sensor could inaccurately measure the amount of air entering the engine, again, stirring discrepancies in performance. Another crucial aspect is the intake air temperature, IAT sensor, which monitors the temperature of the air entering the engine. If it fails, it can lead to incorrect air density readings and poor engine performance. Additionally, any issues with the ignition system can exacerbate the situation, further complicating the cold start process. The symptoms associated with the DTC P050A can manifest in various ways. A rough idle is a common occurrence as the PCM struggles to regulate idle conditions effectively. Drivers may also notice that the vehicle stalls during cold starts, indicating that the fuel-air mixture is not being managed correctly right after ignition. Such failures can lead to poor fuel economy, as the engine may consume more fuel due to an improper air ratio, resulting in less efficient combustion. This problem can also cause increased emissions, as unburned fuel may be released, expanding the vehicle's carbon footprint and potentially violating emission regulations. These symptoms should prompt immediate awareness as they indicate underlying issues in the cold start process. The first troubleshooting step for addressing the DTC P050A is to ensure that the engine is cooled down to an ambient engine coolant temperature of 140 degrees Fahrenheit or less. This step is vital as it allows for valid diagnostic readings and ensures that the cold start conditions are replicated. The engine coolant temperature, ECT sensor, provides this crucial information, which is necessary to determine the integrity of the cooling system and whether it is operating within the specified parameters. Before proceeding with further diagnostics, verify that the ECT sensor is reporting accurate temperatures to the powertrain control module, PCM. An inaccurate sensor reading can falsely trigger or prevent the correct monitoring of the cold start idle air control system. This accuracy is paramount for the subsequent steps in the troubleshooting process to ensure the correct diagnostics of the vehicle's condition. After ensuring that the engine temperature is appropriate, the next troubleshooting step involves starting the engine and allowing it to idle for at least 10 seconds. During this idling period, it's essential to monitor the response and behavior of the Powertrain Control Module PCM. The PCM continuously analyzes feedback from various sensors, including the ECT and intake air temperature IAT sensors. By allowing the engine to idle, the vehicle can meet the conditions for the quick warm-up system to activate. If the PCM detects any discrepancies in air intake compared to the target air specifications during this period, it may lead to the triggering of the DTC. Therefore, assessing the PCM's performance during these crucial seconds will provide significant insight into whether the cold start idle air control system is functioning correctly, or if there is a systemic issue requiring further investigation. Once all necessary repairs and replacements have been conducted regarding the components influencing the DTC P050A, it is crucial to perform a final verification of the repair's effectiveness. Begin by checking the current DTC status through the vehicle's diagnostic tool. If the DTC P050A is present, additional evaluations may need to be conducted on sensors or components that weren't addressed initially. If the DTC has cleared, it indicates that the issues have potentially been resolved. Furthermore, it is advisable to clear the DTC using a scan tool, allowing the PCM to reset and reevaluate the system under normal operating conditions. Confirming the absence of the DTC after several driving cycles will ensure that the repair was successful and that the cold start idle air control system functions as intended. To prevent the recurrence of DTC P050A, regular preventive maintenance is essential. One primary measure is to conduct routine checks on the air filter. A clean air filter not only aids in optimal airflow, but also ensures that the air supply to the engine is free from obstructions, thereby preventing intake air problems. Inspecting the intake system for any leaks or damage should also become part of the scheduled maintenance routine. Early detection of issues can prevent more severe problems down the line, improving overall engine performance and longevity. Furthermore, it is beneficial to monitor the performance of the ECT and IAT sensors over time to ensure they remain in good working condition. Maintaining these components in good order will help the vehicle run smoothly and efficiently, thereby reducing the likelihood of future cold start issues. In conclusion, addressing the DTC P050A involves a thorough understanding of the roles of various components such as the PCM, IAC, and sensors like the ECT and IAT. Monitoring engine performance is essential, especially during cold starts, to detect any irregularities early. Implementing the troubleshooting steps outlined ensures comprehensive diagnostics and repairs, effectively eliminating the DTC. Additionally, regular preventive maintenance, such as filter checks and inspections, must be established to safeguard against future occurrences of this issue. Always remember that proactive maintenance can save time and money in the long run, encouraging optimal vehicle functionality and reduced emissions. Keeping these key points in mind will pave the way for a smoother, more efficient cold start experience for your Honda Accord. Please like and subscribe to the channel. See you next time.